Hi, here is what we're going to do. I don't have time anymore to create classical courses like I did. You have them free online already for C# Rhino development. I created a lot of videos where I show how to create a Grasshopper component from scratch in C#, Revit component, and so on. So since I don't have time for all of that, I was thinking, how can I contribute? And I think I can contribute by making these spontaneous videos where I will actually share my screen and we can go through some things together, where you can imagine literally like we're having a coffee in front of the computer and talking about computational design. And if you're a professional computational designer, programmer, this might not benefit you that much because almost everything I show will be known to you. But it might be interesting to see some thoughts I have. It might be interesting to see what I don't know. When you don't use something for a long time, even if you're an expert in that field, you don't know that. So that might be an interesting part for you to see, and to see how I research stuff, how I think about stuff. So that's going to be like very spontaneous. If you're watching this on some other social media, I don't know where I'll post this, maybe on LinkedIn or on Instagram, you can then head on to my YouTube channel where there will be the full version of this video, the long one, as long as it takes. Let's see. So without further ado, going through some small list that I made here to show you what computational design is about and how it's following some kind of logical steps, like start with some macros, scripting, Grasshopper, Python, and so on. Of course, you will see me Google this stuff, because why I don't use macros, I don't use scripts. I did. The whole Shenzhen airport was done with Rhino scripting. I'll mention that. I do not use Grasshopper. So some of my colleagues in my company, they do use Grasshopper. I actually never did. I use it from time to time. I know how to use it because, as you'll see, I'll explain it. But we do most of our things in C#, right? C# plugins for Revit and Rhino, and you'll see all of that. So without further ado, again, I guess I'll switch to my screen. And we will start with macros, but I have nothing prepared. That's exactly how I want this to go. I have nothing prepared, and if I'm boring you, and if this is too slow for today's internet speed, you can tune out at any time, but this is the best way I can do it, and I know how to do it. So look at what I'm going to do. I'm going to go into Google and Google Rhino 3D macros. Now, this can lead me to some macros, creating macros, but here's what I would like to do, right? Here is the first insight. I write Rhino Developer, and I go to this part here, that's developer.rhino3d.com, and it gives me a couple of these sections, right? Rhino Common, Python, OpenNURBS. This is a very, very nice start. This is a very nice start for me, but we don't have macros here, so we'll switch there just in a second. Let's go here to macros and creating macros. So why am I going to macros? Because that's the first step of automation, let's say. In any program, you have macros in Microsoft Word, you have Microsoft Excel, whatever program. So what does that do is you have this like a macro editor, and you can combine multiple commands together. That's it. That's like the first step into computational design. If you notice that you keep repeating a couple of commands, you extrude something, then you turn it into a solid, then you mesh it or whatever, you can write a macro. And there are a couple of here things that are important. This is this exclamation point. The underscore means that you can write in English. So in whatever language your Rhino is, you can write in English. By the way, if you don't know that, I'm going to open Rhino because now it kind of makes sense to follow along to what we're talking about. My Rhino is in English, but if your Rhino is in German or in Spanish, with an underscore, you can always write an English command. That's why it's there. Now, it's a bit embarrassing that I forgot what this exclamation point is, but here we go with the exclamation point. Here we go with the things that I don't know, because this exclamation point, I use it sometime in code. That's also interesting for you maybe to know that when we write code, we can call Rhino scripts. So I can call actually a script like this inside code if I don't want to program it specifically, and it can just execute it. So I do use exclamation points, but my brain is blocking now, and that will, here, which in a script means end now. It takes you all the way to regardless of how many subvels you're in. So it's used to end the script or the previous script or something like that. So that's it. Those are macros, right? So where do we go after macros? Well, after macros, after you learn how to do this, which is not so useful to be honest, you can go to scripts, right? So let's go to Rhino Developer and to this site, and we have some Rhino script here. Scripting is done. It was done in VB script. I still don't know if this is supported. Might be supported. Let's look at it. Script VB. No, I don't know. The McNeil people will kill me now when they see how I'm butchering all these settings. But if you do write a script and you open the script editor, you will see down here on the left the Python script editor is being opened, and that's the main way in which scripting is done nowadays. I will remind you that I worked on this Shenzhen airport by Massimiliano Fuxas, and in this airport, I used only Rhino script, that was VB script then, to generate this entire facade and this entire structure in between. You don't see the structure in between, it's crazy. So you have the outer shell, facade shell, inner facade shell, and in between a lot of structure. Let's see if there are some images of structure. This was done when I was working for my professor Knippers in the Knippers Helbig office. You can see here how the structure in between looks like. Those are all, of course, individual steel members and profiles. This is like 300,000 square meter of double curved facade. And this was all generated at the click of a button using Rhino script in 2008 or 9, the VB script. But here we come today, and Python rules the world, so it's done in Python. Guess what? I don't know Python. I don't use Python. I know the basics of it. I mean, I can use it, especially with the help of AI nowadays. And I used it a little bit because I was trying to program my own neural networks and my own AI things, following Andrei Karpathy's videos. But that's my extent. When it comes to Python, I don't use it. And but I encourage everybody to use it as much as they can, because it's really cool, and you have a lot of free libraries online that you can use. So this is the scripting part. Why is this another step in programming? Because now suddenly let me check this. Okay, now suddenly with scripting you can do a little bit more. You can write this entire functions, right? You see here you can import different libraries, you can use their functions, and then you can start actually programming. Here there is some mesh that is done from a specific object after the scene is imported, and blah blah blah. So you can create these entire functions and call them. You can even connect multiple functions, and it becomes a true kind of programming. My scripts for the Shenzhen airport, there were 3,000 or 4,000 lines of code, and I had no debugger then. That was, I remember I talked to someone, they couldn't believe it, and at the moment I didn't know that debugging was a thing. My script would crash, and I would guess where it crashed. I had no idea how to find that out any other way. So in the 3,000 lines of code, I would go to line 550 and assume that that's here. Here was the problem. Let's go. So you can do like this for loops, if functions, conditional logic, everything is there. Everything is there. It's just that the normal like object-oriented programming later, it offers even much more. Which brings me to Grasshopper, right? A lot of you, most of you that do something with computational design do it in Grasshopper. And Grasshopper is kind of a visual programming, right? So for those that do not know and are watching this video to see what computational design is about, After you have macros, after you have these scripts and functions, you can use Grasshopper. Before I show Grasshopper, though, I don't want to just fly over this. I just want to show you, because I want this to be a bit clear to you. You see, you have like a play button here. That means you can play this script. So whatever you write there, it's like instructions for macro. It's just more complicated, and you can simply play it. This means that there are some functions here that ask you to select geometry, and then that geometry will be saved after you select it, and then you can do something with it and so on. So that's how it works, but this is the user interface for scripting. You can play from it, you can save it, you can even make your own buttons that call these scripts. That's not hard, but that's kind of the extent, and you can do a lot of it. But now going back to Grasshopper. Grasshopper is done for people that don't want to write code, that they're maybe intimidated by code. And they created like a pre-made functions, a lot of functions, and they wrapped them into these nice looking visual components. So there's a lot of these components, and the simplest one for you to understand is addition, right? You have A and B number, and this component is simply a function. It does A plus B. So that means that somewhere there has to be a number node, okay? With the right click, I can set it to 10, and then I can copy paste it, and then with the right click, I can set it to 20, and then there will be some result here. I need a way to see the result. I can hover, and I can see that it says one locally defined value is 30, but I can display that in a panel. And this is why Grasshopper was invented for people that are maybe intimidated by coding or don't want to go there. They still will program, they just do it visually. So the simplest way is you create these linear things, and then you see those spaghetti monsters, right, that come out of Grasshopper when you start connecting this linearly. But you can do much more complicated things in Grasshopper. You can do also loops, and you can wrap this into package it into a single component and then make it clearer, and so it approaches actual programming. But from my point of view, it's much harder to handle. I mean, look at how the adding of two numbers looks like, right? And the adding of two numbers in the code is literally just a couple of characters. So you can imagine if you want to do something more complex, it can happen that few lines of code, 2-3 lines of code, can turn into 15, 20 components here. That's what you have to be careful about, and that's why, for me, from my point of view, there is like a limit to Grasshopper, right? Limit. When I say a limit, I mean I talk about a complexity limit. So there is a certain type of complexity that you can reach with Grasshopper, but when you start to push over that, that's really hard. And secondly, it's a problem of speed, right? So everything you manually draw here, it needs to be translated into some kind of code behind, and then that code that gets executed. So you're losing a lot of time with this translation. Yeah, so everything is much slower if you do it in Grasshopper than in code. For scripting, I don't know anymore. Before with scripting it was the same. It had to be translated into some lower level like C++ or something. My guess is that with Python it works the same now. People can correct me, that it still needs a type of a translation to Python, I think, translate to C, and then it goes further. So it is slower than if you write low-level code, but it is much faster than Grasshopper. So inside Grasshopper, now you can then do scripting. Like I told you that if you write do a couple of components like the ones we had here, there are some ways you can package this into, like, you can cluster it, so it clusters it into one thing, and then you can open it and so on. So you can create your own function, so to speak. But look at me working in Grasshopper like I know what I'm doing. But you can create your own components, and the first step of creating your components are the actual Python and C# components here. So Python is like a Python script here that you can double click and open, and now you have that same script like you had before, but it's just wrapped here in a component. And the component, as any function, it has input and output. And you can control here the input and the output. To be honest, I don't know how to do it here. There is a C# component where you can do the same thing, only with C#. So you open it, and the coding is a little bit more complicated. So you will see this X and Y. They will be like inputs, and then you will see this reference object as an output. So in theory, let's see if this works. I can say X plus A equals X plus Y, right? And then we can delete this null thingy. Then we can, sorry. Aha, you see, you cannot apply operands of object. So I'm guessing I need to put it, you see how much I use Grasshopper? This is how much I use Grasshopper. So it needs to be the variable, cannot be object. You know, object is generic one, and then you would have to cast it into something. But if I set this to be a number, then it can work, and hopefully it can work. And then you will get here a number. Of course, we will again need some numbers. And you know, in Grasshopper, you also have these number sliders that make it a little bit more easy to do something. But you see, we created our own addition. I can change here to integer, and I don't know, and on any type of a variable, and Grasshopper will, I think, automatically help me see what kind of objects am I putting in. So this is so here you can also start creating complex things in C#, right? You can do this and then create functions and so on. And that is how you now, instead of million components, you can create 1, 2, 3, 4 of your own that are very complex, but they call the complexity inside. So that was the next step. And then without now wasting too much time, you can go into the next step, which is the creating actually Grasshopper components. Now I'm going to open Visual Studio to do this. I'm going to create a new project just to remind myself. I did make videos about this, but I don't use it, and so I forgot about it. You see, we have Grasshopper assembly for Rhino, so you can create not only your components, you can create your own toolbar here like this. For example, here it says Milos, right? I was testing something. Here it says Duo. It's some components that we were developing with an architectural office, DTFLR. So you can create like a whole toolbar with different commands. And that's what you do in Visual Studio using this Grasshopper assembly for Rhino, which comes directly if you install this Rhino extension that you need to create Rhino plugins. This comes with it. So let's say we want to create that. I will select some my Grasshopper assembly, whatever, and you will see that after some couple of settings, we will create like a Visual Studio project. And inside that Visual Studio project, in the moment it creates it, there are some components. You see, there is a first default component. And then you will see here register input parameters, register output parameters. What are those? Those are these X, Y, and A. And I can immediately register for my component what are my input parameters, what are my output parameters, and then solve the instance. So this is the function, like this is the black box that does something with these parameters. And then you have like user interface stuff and so on. Now you can create a proper project, proper Visual Studio project. You can do the object-oriented programming. I'm not going to talk about that. As I said, you have a 10+ hour free course on my YouTube channel for Rhino development. C# you have for C++, the older one, but I don't recommend that necessarily. I switched to C# from C++. I worked in C++ for the first 4 or 5 years and then switched to C#. I talk about it in other videos, don't want to make it just too technical. But so if I want, this is just a single component, right? This is just in Grasshopper, this is, did I close it? This is one of those things, one of these buttons that will create one component. And then if I just want to add another one, I'll go and probably add a new item. And Rhino, here, there is an empty Grasshopper component. So I will add a test component. And it will have the same things. It will have the name that will appear there on the component, the description, the category and subcategory, so that it knows where to fit it here. You can fit it also in one of these categories and subcategories, or you can make your own, like I did here. And then you just write some code, and that's it, like easy, right? That's how this Grasshopper scripting works. And since I don't want this to make this video now 7 hours, let's cut it short. We're coming to the final step of creating full project. And I can do that by going to new and create again. Let's do it again, just for you to see that it's nothing special. I can go and say create a new project. And now I will choose this Rhino Common plugin for 3D. Again, this comes when you create when you follow those steps that you see also in many other videos of mine and even online. When you go here to the Rhino Developer, and you go here to Rhino Common, which is the name of the library for C#. Then you can see here creating a Rhino plugin and so on. Those first steps. But let's create some Rhino plugin. The name doesn't matter. We'll take it that it's a general utility. You can create specified plugins for file import, file export, or rendering, and so on. But most of the time we need general utility, and we can see a command sample here. And then I will show you how the much more complex plugin looks like. And see, like you saw there with the Grasshopper and the component, now in Rhino plugin you don't have a component, you have a command, right? So now you can execute that command, you can call it from here. Or you can create your own toolbars and so on, but those toolbars and these icons do nothing else. They just call commands, and those commands are registered here in Rhino. And then you can see that I basically have the name of my command, which should be unique. There's some IDs in the background. And then this is a sample command that executes some code. We're not going to go into coding now, but you can see that there is some line it will be written. So this will be written in that command prompt. And then there will be some point that we will ask the user to select a point. And whatever user selects, it will be saved in this variable, pt0. Then we will repeat that exact thing in pt1. This is one thing where you can see that some repetition maybe could be exported into functions and so on. And then there will be some dynamic drawing of a line. So what this command does is just dynamically draws a line. And at the end, you see there's our document, which is the Rhino document. It has a table of all objects inside the document, and we are adding a line to that table. We're adding a line with this start point and this start endpoint to the document. We're redrawing our views, and then we are informing the user that the line was added to the document. This is that sample plugin. And then you can go here, right-click to your project, and you can say new item, and you can say then here Rhino, empty Rhino common command, and then I can get my new command, and this new command has no code inside. It will do something else. Of course, how the project works, and can get very complicated, and now you can start doing some really cool stuff. I'll show you, like I have my gas plugin open, and you see it has a huge structure, right? It has some conduits for displays, it has different commands here, and then it has a lot of different functions and classes. Also this object-oriented programming, we're not going to go into that now, but grouped into some logical components. We have user interface here. We have some views and view models. Views are just windows. So here is our gas manager window, and that I can adjust here. And if I go into my Rhino and I say gas command, I can see this is the same thing that you saw there. This is some tool that we use to track assets in our projects and so on. I'm not going to describe our gas tool. You have some videos about that, but it's still very internal, but very powerful. We have some agents here that creates builds of materials, that check for clashing, creates automatic fasteners, creates automatic sequencing. and so on, and then some models here. And I want to show you that this can get very complex, but you can then create true software. You can create these user interfaces with dialogues where whatever here it is. Now let me check. All this require that I select something. So this is some bill of materials editor and so on. So you can do all of that. Now let me check how long this video is. It's already pretty long. We're closing up half an hour. So I'll just I wanted to give you a slight overview. Right? Let's do some revision of what we said. You can do some macros. You can do some macros. Then you can do some scripting. This Open NURBS is just a NURBS library that if you want to learn about geometry itself, but that's not necessary here for the development. You have Rhino Python for scripting after macros and this VB scripting if it's still alive. And then you can move to Grasshopper and visual programming, and then you saw that you can then insert scripts into Grasshopper. You can create your components inside with those C# components, but you can create those components outside, like you create them completely in the Visual Studio as a project, and then as the last step you go and create this full C# or C++. I mean, C++ still works, but it's faster. It's the fastest possible solution. But I switched to C# because it's managed and it's much more easier to control, and you have some libraries that you can use and so on. And so that's the way. So this Rhino Common API will give you this full access to Rhino geometry, documents, user interface. You can do basically everything that a McNeil programmer can, right? Maybe a couple of things I wrote down here, a couple of things that are interesting to mention for a programmer, and that is that there is a Rhino 3D MEO library. I don't know if it is here mentioned. So you can see that. Is it deprecated? I don't know. Here, someone is asking on the forum. Anyway, or 3DM, it's called 3DM now. It's a library that's free. So this is a DLL. It's the DLL that makes you create your own software that calls some of Rhino geometry in the background. Like you don't have to open Rhino, you don't have to own Rhino license or whatnot. It's just an open source library of geometric tools, and whatever you create, like you can create like Python programs, JavaScript programs, .NET programs, and you can call this library. Now, advanced extension of that is the Rhino Compute. Now, Rhino Compute is basically a whole Rhino in a single DLL. So they managed to somehow wrap the whole Rhino into one DLL so that you can use it to call it from different programs. And maybe you've seen this, you've seen Revit inside Rhino. That's what it uses. It basically uses all these Revit functions and methods and calls them and connects them with Revit. You can use them. There's lots of examples of people using them in Unity, in Unreal even. So you can connect from your software or from any other software and get the full Rhino package of methods and classes and everything. To use the full Rhino Compute, you do need a Rhino license, which makes sense. But for the Rhino 3DM, you don't. And Rhino Compute, the cool thing about it is that it also works online. So that's a huge subject that I'm not going to talk about now. But you can see on my channel, here I'm opening it now. I'm searching for my channel. And the Rhino Compute. Yeah. So you see, like 4 years ago, I had a conversation with McNeil programmers, with Steve and Louis and Will, and we talked about it. But since then, there has been a lot of development, and this Rhino Compute is something where you can put Rhino on the server. You can spin instances of Rhino Compute on the server. Sorry, my camera just went off. I had to turn it back on. So you can spin instances of Rhino Compute on the server, and you can spin many of them at the same time and basically do the calculations in the back end. That's usually made for web development, so you can make some kind of configurators online and so on, and then those configurators, whenever you push and pull some sliders, they can call Rhino Compute on the back end, on the server, compute the geometry for you and take it back to the front end, to the browser. So Rhino Compute is a very big deal and a very cool thing. It's Rhino as a service, and there is as I said, here is like a long conversation of an hour, but there are a lot of companies that talk about it and implement it, and I'm not going to go into that now. I just wanted to mention that's also this thing. And let me close with talking about a little bit about this developer mindset, because that's what I wrote down here. It's important to end with. With developer mindset, you basically, you tend to automate once and reuse forever, right? That's whenever you notice there is something that keeps repeating, you start writing macros, you start writing scripts, but then you create a library of your own tools. And even if you think like that, maybe you'll run out of the tools, you'll make them all and that's it. You see that our society always progresses in complexity, and you will realize that you can always move into the pyramidal shape, right? You can always pack those tools into more tools and make more complex tools that use the ones that you already did and follow that road. I will advise you, if you're on this road, to try to document everything very carefully. Now AI is helping with this, not only to document but also to search documentation, which is very cool. You will expect a lot of frustration, a lot of stress. I love this t-shirt that I saw, or something that says, I hate programming, I hate programming, I hate programming. Wait, it works. I love programming. Something like that on the lines. But there's a lot of frustration until the code works. But when the code works and you manage to automate something that you needed 5 hours to do manually, and now you can just click a button, then it's very satisfying, and it's very good for the industry. Because I mentioned this in many other videos, we don't develop tools to take jobs from the architects or to take creative side. We want to free your time and my time and our time to do creative stuff. That's why we program. I only have ideas of tools that are automating the boring stuff. When I don't have ideas or I don't work on anything that will automate the creative stuff, just I start from the bottom up, right? What's the most boring thing? What takes the most time? Let's automate that, and then we move upwards. But whatever is creative, we don't really touch that. It's not of our interest. It's important if you're a developer to develop this to develop this sense of precision and responsibility. I find that important. Maybe some people don't. Maybe they want to use parametric design for artistic or creative expressions. That's okay. But I work a lot in fabrication and so on, and Rhino is an amazing geometry engine. The precision is very important for them. So you can create very, very, very precise things. We work with 0.001 millimeter precisions, fabrication models, send everything to the CNC machine. So Rhino is this raw tool, this raw geometry engine that you can use then to put whatever you want on top of it. It's like the best car engine, and now you're building a car around of it instead of buying like a car that's someone already pre-made for you. And so you just have to learn to think like a tool maker. Sometimes I wonder why people think like, oh, it would be cool to have this, but they don't think about making it themselves. Even in our company, sometimes I notice and I have to keep asking. I said, do you think that tool could help us with that? And then they say, okay, well, actually, can we make a tool? No, we can't, right? And after that, no, we can't. It turns out that we can in 5 hours. And then suddenly we sped up something that was done manually for 30 minutes. It takes 5 seconds. So always questions what tool you can make. And most of them you actually can. If you are just at the beginning, if you want to start small, follow this road, go macro scripting, Grasshopper scripting, and so on. Because everything you learn builds on the previous step. Everything is interconnected. And if you can imagine it, you can automate it. Let's finish that and continue in some of the next videos. Subscribe to the YouTube channel, follow on LinkedIn, even on Instagram. I'm starting to post now, and I will make a lot of these if you're interested in. There is a lot to talk about. There's a lot of structural analysis, optimizations, genetic algorithms, precisions, nerve geometry, mesh geometry. The subject is endless, so I will not have time to prepare any videos. So if they will be spontaneous like this. So you have to be patient. You will have to take your time aside for like having coffee with me. And then I hope I will be able to help you, attract you to the field, and make this world better. Stay free. Talk to you soon. Bye-bye.